Okay, in number 32, it says solve each exponential equation, round to 4 decimal places as needed. So I want to remind you, if you look here, we have 5 to the negative 1 power equals 5 to the 2x power. We learned that if we have the same base with two exponential expressions, if these two expressions are equal, then the exponents also have to be equal as well. So 2x must equal negative 1, so x equals negative a half. So that's one type of problem we run into when we're solving exponential equations. The other type would be one like this one here, where you have 5 to the x power equals 12. Notice I can't write 12 as 5 to some power. And so in this problem, I'm just going to have to do something different. And in fact, notice the variables in the exponent. We learned all we need to do is change this to log form. So that's going to be log base 5 of 12 equals x. Now some of you can put that into your calculator directly. Others of you will need to use the change of base rule. So the log of 12 over the log of 5. Make sure you put parentheses around that 12 and 5. And then when you simplify that, you get your answer when you put that in your calculator. So let's go ahead and do number 32 here. We can write 9 or 1/9 as 3 to the negative 2 power. Remember, 3 squared is 9, so we know 3 to the negative 2 would be the reciprocal of that, which is 1/9. So here, our exponents have to be equal since our bases are equal. So x minus 4 equals negative 2. Let's add 4 to both sides, and we get x equals 2. Alright, so that was similar to the first problem that I mentioned earlier, this one over here. Let's go ahead and look at part B. That's more like the second problem we looked at, this one down here. Notice I can't write 5 as a power of 2. And so we're going to need to change to log form. Again, we have the variable in the exponent. So this is log base 2 of 5 is equal to x. Again, some of you can put that in your calculator directly. Others will need to use the change of base rule. And you should get 2.3219. Notice it says round to 4 decimal places, and so that's why we're doing 4 decimal places. Alright, on letter C, we have a base E exponential equation with the 3 parts. So in this one, we're going to need to write this as, let's see, we could write it as log base E of 8 is equal to 0.12x. But we don't write logs that are base E this way. We write it as a natural log. And now we just need to divide by 0.12. So on the left you have the natural log of 8 divided by 1200ths. So when you throw that into your calculator, you should get 17.3287. Alright, let's look at 33. So just as we had with exponential functions, with log functions we really have two basic types. So let's talk about that. We could have a situation like this, where we have log equals log. Natural log equals natural log. They have to be the same base. And so what we learned is in order for this to be true, the inner parts of the log must be equal. So we set 4x equal to 3x minus 2. Subtract 3x on both sides, you get x equals negative 2. Now notice in this problem, if you plug negative 2 in right here, 4 times negative 2 is negative 8. You'd be taking the natural log of a negative number, which we learned is not defined. You can throw that into your calculator and you'll see that there's no answer there. It's not defined. So don't forget to check that. You can't take the log of a negative. So when we have log equals log, that's one of our two cases. But what if it's a problem, actually let me finish that one up. So we have no solution for that one. Let's move on to this one here. These are just some problems I made up just to kind of summarize what we've done. Notice here we don't have log equals log. And so in this case, the only thing I can do is switch forms. Notice I've got the three parts. I have base, exponent, answer. So let's go ahead and write this in exponential form. We have 3 squared is equal to 4x plus 1, or 9 equals 4x plus 1. Let's go ahead and solve this. We're going to end up getting x equals 2, and that actually does work. Now let's go ahead and look at the problems that you were assigned. So on letter A here, this is the case where we don't have log equals log, and so we're going to have to change forms. Actually, let's do part B first, because notice in that one we do have log equals log. I'm going to do the easy one first here. So we want to set our inner parts equal, so 5x minus 1 equals 2x. Subtract 5x on both sides, divide by negative 3. We're going to get x equals 1/3. And if you plug 1/3 into each side, you end up taking the natural log of 2/3 on each side, and so you are equal, and you're certainly not taking the log of a negative. So that does work. So now let's look at A. So in this case, we do have to change to exponential form. We don't have log equals log. And so 3 to the 4th, that's 81. And this is just a two-step equation. We'll add 2 to both sides, divide by 3, and we get 83/3. Not the nicest number, but if you plug it in, you're doing 3 times x, 3 times 83/3, that's just 83, minus 2 is 81. The log base 3 of 81 does equal 4. It does work. Let's go ahead and look at number 34. So notice on the left side you have 2 logs, and so we're actually going to need to combine those together using the product rule. Since we have a sum of logs, we can write this as the log of a product, and on the other side we just rewrite it. So here we do have log equals log, so we can set our inner parts equal. So I'm going to go ahead and FOIL that left side out. On the right side we have 4, and I'm going to subtract 4 on both sides. Because you can see this is a quadratic equation, I want to get that 0 on the right side. So let's do that. We're going to get x squared minus x minus 6 equals 0. So let's go ahead and factor that. We can use AC method. It looks like we're going to use 3 and 2 on this one, and we need the 3 to be negative, because 2 times negative 3 is negative 6, and 2 plus negative 3 is negative 1. So we can factor this one as x plus 2 times x minus 3. Notice since we had a 1x squared, we can use the shortcut here. We're going to get negative 2 and 3. But don't forget, we can't take the log of a negative. If you plug negative 2 in, you're going to have issues, so we got to throw that one out. So 3 is our solution. You can check that that does work. Alright, let's move on to 35. Alright, so we got one more log here. This time we're going to have to use the quotient rule. We got a subtraction of 2 logs. So this will be the log base 2 of x plus 6 over x minus 1. On the other side we still have 3. So notice we do not have log equals log. We cannot set the inner parts equal. So all we can do is change form. So we have a base of 2, an exponent of 3, and the answer goes on the other side. Let's change that 2 cubed to 8. We need to clear fractions, so let's multiply by x minus 1 on both sides. We are going to get 8x minus 8 is equal to x plus 6. And you can subtract x on both sides. And now you have a two-step equation. You're just going to add 8, divide by 2, or 7, and we get 2. So you can plug that in, and that does work. Alright, let's look at number 36. So we've got the PERT formula here. And in this problem, the starting amount is $5,000. And the interest rate is 0.045, written as a decimal. So if we plug let's see, t we don't know. That's how long it's going to take. We don't know that. Let's go ahead and plug in what we know. Well, look like we need an a. Well, think about this. If we want to find out how long it's going to take for $5,000 to double, then a is going to be twice whatever p is. So that would be 10,000. So we want our money to double from 5,000 to 10,000. So a is 10,000. That's the amount we want to have in the account after t years. Alright, so let's go ahead and look at this. Notice that 5,000, it's like an extra number there. If we didn't have the 5,000, we would have base, exponent, answer, but we got to get rid of that 5,000. So let's divide by 5,000. Since it's 5,000 times e to a power, we're going to get 2 equals e to the 0.045t. So now we do have the three parts, base, exponent, answer. And so we can go ahead and notice we have a variable in the exponent. We're going to want to write this as a log. It's going to be a natural log too. So natural log of 2 is equal to the exponent, which is 0.045t. So we need to divide by 0.045. So if you take natural log of 2 divided by 0.045, you get about 15.4 years. You can actually plug that into the original formula where you don't have an a, and you can verify that it does work. In 15.4 years you will have $10,000 or something real close to that. Alright, let's do one more. Let's look at 37 here. Let's see, Jack loves chips and salsa. So let's see, he went to the store, he got 2 bags of chips and 3 jars of salsa for $10.45. Then he got 1 bag of chips and 1 jar of salsa for $4.10. Determine the price for each of these items. Alright, so first of all, we have to find the price of chips and the price of the salsa. So there's my x and my y. I'm going to use x and y here. So let's see, 2 bags of chips, the cost for that would be 2x. The cost for the 3 jars of salsa would be 3y, since each jar has a price of y. And that's equal to $10.45. And then we know 1 bag of chips and 1 jar of salsa, so that would be 1x plus 1y is equal to $4.10. So we can solve this system using any method that we want. Substitution and elimination both would work quite well. But I'm just going to go ahead and put this into the calculator as a matrix, which you can do or use whatever method you want. So when you do that, remember we got to use that RREF feature, and you get what I have here. So you can see that x is 185 and y is 2.25. So the price of chips is 185 and the price of the salsa is 225. Alright, so we're going to stop this video here.